question here is asking us to determine the magnitude of the resultant force at A. We're looking at this question here, and we can see that two forces applied on the post. Each one of them is being given at a specific coordinate positions. Now, to find the magnitude of the resultant force, first we need to find the resultant force itself. So the resultant force itself, Fr, equal to FAB, the first force applied in there, and FAC. FAB itself, FAB equal to FB, the force applied, multiplied by the unit vector B. So we need to find the unit vector B. Unit vector B equal to the position vector RAB divided by the magnitude of that position vector RAB. To find the position vector RAB equal, we look at this diagram in here, we can see that it's the positive 3 meter on the x-axis. For this force in here, it's positive 3 meter on the x-axis, negative 2 meter on the y-axis, and also negative 6 meters on the z-axis. It's negative because it's pulling downwards. Since the impact of the force it's downwards, therefore it will be negative on the z-axis. Now we found that positive 3i minus 2j minus 6k. This is the position vector that for the AB. Now finding the magnitude of that position vector, the magnitude of the position vector RAB equal to, we take the square root of these coordinates and we square them, sum all of them together, and all of that should equal to 7 meter. And those 7 meter, now we can, if we divide the coordinates by the magnitude, here we get the unit vector. So unit vector UB equal to 3 over 7i minus 2 over 7j minus 6 over 7k. Now that's the unit vector. Now finding the force FAB, that force now equal, we know that FB itself is being given 840 Newton, and we multiply it by 3 over 7i minus 2 over 7j minus 6 over 7k, and this force it's in Newton. Once you plug all of this in your calculator, you should get 360 I minus 240 J minus 720 K, and this one now it is the force FAB. We will do the same things for the force FAC, which equal to the force FC multiplied by the magnitude unit vector C. In this case we find in the UC first, which equal to the position vector AC divided by the magnitude of that position vector RAC. Then the position vector RAC itself should equal, when we look at this diagram in here, we can see that it's positive 2 meter on the x-axis, positive 3 meters on the y-axis, negative 6, 2, 3, negative 6. So positive 2 on the x-axis, positive 3 on the y-axis, and finally negative 6 meter on the z-axis in there. So the magnitude of the RAC equal to the square root of the sum of these coordinates in there. Again, that should equal to 7 meter. Now finding the force itself, FAC, which equal FC is being given to be that is being given to be 420 Newton. We will multiply it by 2 over 7 I plus 3 over 7 J minus 6 over 7 K. Of course it's in Newton. Once you plug all of this in your calculator, that should equal to 120 I plus 180 J minus 360 K. And of course this force in here, it's in Newton. Now we found FAC and FAB. We are going to add the I component together, J component together, and K component together. FR equal to FAB plus FAC. That should equal to, we adding all of these components together, and that should equal to 480 I minus 60 J minus 1080 K in Newton. We found the force FR. The magnitude of FR must equal the square root of 480 square minus plus, that's negative 60 square plus negative 1080 square. All of that should equal to 1183.4 Newton. This is the magnitude and how to find it of the resultant force. Finding the position vector, the magnitude of these position vectors, then you divide both of them together, then you multiply that unit vector by the given force in there, and that's, you add all of the forces together to find the resultant force itself, and then get the magnitude. See you guys in the next video for more questions like this.